Assalamu alaikum. Welcome to e-learning Al-Noor International School Grade 12 Chemistry course. I'm your chemistry teacher Faraz Anju. In this week we will study chapter 25 Nuclear Chemistry, lesson number 1 Nuclear Radiation. For the reference we need textbook page number 876 till 879. So please open your textbook. This week, our main objectives are explain how an unstable nucleus releases energy and describe the three main types of nuclear radiations. So let's start. What makes some type of radiation more dangerous than other types? Lengthy or frequent exposure to X-rays can damage cells in your body. Radioactivity. How do nuclear reactions differ from chemical radiation? Okay, in 1896, the French chemist Antoine Becquerel made an accidental discovery. He was studying the ability of uranium salts that had been exposed to sunlight to form photographic film plates. During bad weather, when Becquerel could not expose a sample of sunlight, he left the sample on the top of the photographic plate. When he developed the plate, he discovered that the uranium salt still fogged the film. So, two of the Becquerel's associates were Marie and Pierre Curie. The Curie were able to show that the rays emitted by the uranium atom caused the film to fog. Marie Curie and her husband Pierre shared the 1903 Nobel Prize in Physics with the Becquerel for their pioneering work on radioactivity. Marie Curie used the term radioactivity to refer to the spontaneous emission of rays or particles from certain elements such as uranium. So the ray particles emitted from a radioactive source are called nuclear radiation. So the difference between what? Radioactivity to refer the spontaneous emission of the rays or particles from the certain element such as uranium. This is called radioactivity. And the rays and particles emitted from the radioactive source are called nuclear radiation. Radioactivity, which is also called radioactive decay, is an example of the nuclear reaction. Nuclear reaction begins with unstable isotope or radioisotopes. Atoms of these isotopes become more stable when changes occur in their nuclei. The changes are always accompanied by the emission of the large amount of energy. Unlike chemical reaction, nuclear reactions are not affected by the changes in temperature, pressure, or the presence of catalyst. Also, nuclear reaction of a given radioisotope cannot be slowed down, sped up, or stopped. So, radioactivity decay is a spontaneous process that does not require an input of energy. Okay, so spontaneously means automatically it can going to be radioactive. When you open it, it starts. If the product of the nuclear reaction is unstable, it will decay too. The process continues until unstable isotope of one element are changed or transformed into the stable isotope of a different element. Okay, so keep going. This is a continuous process. These stable isotopes are not radioactive after that. Okay, so why do unstable isotopes undergo the reaction? So unstable isotopes undergo the nuclear nuclear reactions so that they may be changed or transformed into the stable isotope. Simply, you can say you are going after the study, you are going for the struggle for the jobs or a business. This struggling period, what you want to become stable, to get the proper or good job, or after study you will get have a good business, okay, or you are going to achieve your goal. So what to do? Struggling period like a radioactive isotope, which is unstable. After getting job and getting a good business, you become stable isotope. Okay, type of radiation. There are three types of nuclear radiation. There's many types. Yes, radiation is emitted during the radioactive decay. Three types of nuclear radiation are alpha, beta, and gamma radiation. Okay, so how many? Alpha, beta, and gamma radiations. So here and we will discuss the characteristic. Start with this alpha radiation. Consists of alpha particles, which is helium nuclei. Okay, which is alpha means helium. Remember, okay, alpha particles means helium particles, which have two proton and two neutrons as well. The charge is 2 positive and mass is 4, and common source is radium. Okay, and penetrating power is low, which is 0.05 millimeter body tissue. Now, second thing is beta radiation. This kind of radiation called beta particles or electrons. Okay, this one is nucleus. Remember, alpha particles, nucleus. Beta particles, electron. Okay, in electron, you know this one, charge is -1 and the mass is 1 over 118, 1835. From which? From proton. Comparison is with the proton, electron with proton. So electron is much lighter than the proton. Okay, carbon 14, the common source, and moderate 4 millimeter of the body tissue. And the gamma radiation, the high energy electromagnetic radiation, which is gamma radiation, no charge, which you can think that as a neutron. We are talking about it. Okay, so 0 and mass is 0. You can say this. Okay, cobalt 60, very high, penetrates body easily. Okay, so how many? Alpha, beta, and gamma radiation. Alpha has 2 positive charge, beta -1, and gamma no charge. Some radioactive sources emit helium nuclei, which are also called alpha particles. Each alpha particle contains 2 proton and 2 neutron and have a double positive charge. Remember, sometime in the SAT exam or during the exam, the question many times it appears that in this exam paper that which particle is the heaviest, electron, proton, or alpha? So the answer will be alpha, because alpha particles contains 2 protons and 2 neutrons. Okay. Now alpha particle is written 2 and 4 or alpha. The electric charge is usually omitted. So the isotope uranium 283 emits alpha radiation and is transformed into another radioisotope thorium, which is 234. From 238 it becomes 234, means 4, which is helium. The mass change going to be changed. This is atomic mass, remember. So uranium, which is 238, the mass uranium, going to convert after decaying. What happened? It released the alpha particles, alpha radiation. After releasing this radiation, these particles, what happened? It changed and formed the stable isotope. Now, when an atom loses uses an alpha particle, the atomic number of the product is lowered by 2 and its mass number is lowered by 4. You can see here. Okay, it's removing the alpha particles means has to be less 2 proton and less 2 and 2 means 2 proton plus 2 neutron as well. So here the atomic number going to be changed, and when the atomic number change, definitely the element going to be changed itself, means totally transformed. Okay, so in the balanced nuclear equation, the sum of the mass number superscript on the right must equal to the sum of the left. Okay, you can see here 234 plus 4 is equal to 238. Means these sum up of these two red one, which is mass number, must be equal to this mass number. Okay, the same as true for the atomic number as well, which is subscript. This is atomic number. Okay, so this atomic number must be equal of the sum of these two, which is 90 plus 2 is 92. So because of their large mass and the charge, alpha particles do not travel very far and are not very penetrating. A sheet of the paper or the surface of your skin can stop them easily. But the radioisotope that emits alpha particles can cause harm when ingested. When ingested, once inside the body, the particles do not have to travel far to penetrate soft tissue. Beta radiation. An electron resulting from the breaking apart of a neutron in an atom is called a beta particle. The neutron break apart into a proton which is remain in the nucleus and the fast moving electron which is released. Okay, now you can see this is the neutron. Okay, when it releases the one electron of the beta particles, okay, when it releases, so what will happen here? Proton going to be formed and electron going to be produced. So the neutron breaks apart into proton which remain in the nucleus, this one, and a fast moving electron which is this, which released. So as we discussed just now, that beta radiation means this beta particle going to be released. The symbol of the electron has a subscript -1 and a superscript 0 because the mass is negligible, very less. The -1 represents the charge of the electron and 0 represents the extremely small mass of the electron compared to the mass of proton. Now carbon-14 emits the beta particles as they decay and form nitrogen-14. So this is the decaying of the carbon-14. So you can see here carbon going to decay. After that it's going to be converted into the nitrogen and beta emission. Okay, so carbon-14 is radioactive element, remember. Okay, not the simple carbon. Simple carbon is carbon-12. The mass is 12 here, but carbon-14 is radioactive. Okay, isotope. So you can see here. So carbon-14 going to become stable. How? By releasing the beta emission electron. Okay, so when it going to beta emission electron, the nitrogen-14 atom has the same mass number as carbon-14. You can see here the both are same, but its atomic number is increased by 1. Okay, atomic number going to be increased by 1. Okay, it contain an additional proton and one fewer neutron. Okay, it means it's contain one additional proton and one fewer neutron. You can see here. So it becomes 7 and one is going to release the one electron. A beta particle has less charge than the alpha particles and much less mass than an alpha particles. Thus, the beta particles are more penetrating than the alpha particles. Okay, so beta particles can pass through the paper but are stopped by the aluminum foil or thin piece of the wood. Because of their opposite charge, alpha and beta radiation can be separated by an electric field. Okay, you can see here, suppose this is the radioactive source, then the slot, from the slot it will come, then electric field is a positive and negative. So alpha particles move towards the negative plate. You can see alpha particles move towards the negative plate because alpha has positive charge. Beta plate move towards the positive plate. Beta going to be positive because alpha, beta has negative charge and attracted by the positive. Gamma rays are not deflected. See, the gamma is going straight. It means gamma have no charge. Now let's start with gamma rays. High energy photon emitted by a radio isotope is called gamma rays. A high energy photon are a form of electromagnetic radiation. Okay, so nuclei often emit the gamma rays along with the alpha or beta particles during the radioactive decay. Take the example of TH, which is 230. Okay, mass. So what is it? What going to be happen? Here is the decaying process start. When after the decaying, you can see it release the helium, which is alpha particles. Okay, and then from 230 it gave you 226. Okay, means it's changing the alpha. One alpha particle is going to be released, and along with a gamma rays, it's going to release the gamma rays. Okay, because high energy photon emitted. Okay, now look here, another TH, which is 234. Okay, remain the same here, but you can see 90 become 91 as like a beta particle here instead of alpha, okay, which is releasing beta particles and a gamma rays. Okay, so 90 become 91. Okay, and beta particle going to be released. Now, gamma rays have no mass and no electrical charge. Emission of the gamma radiation does not alter the atomic number or mass number of an atom. Because gamma rays are extremely penetrating, they can be very dangerous. So gamma rays pass easily through paper, wood, and the human body. They can be stopped, although not completely, by the several meters of concrete or several centimeters of lead. So you can see that alpha particles stop here on the paper. Beta cross the paper but stop by the wood. But gamma can penetrate in the through the paper, through the wood, and through the lead as well. Gamma rays can be dangerous because of their penetrating power. What property determines the relative penetrating power of the electromagnetic radiation? So the wavelength and the energy of electromagnetic radiation determine its relative penetrating power. Gamma rays have shorter wavelength and higher energy than the X-rays or visible light. So checkpoint please. Answer is beta emission. Okay, the quick key point here. Unlike the chemical reaction, nuclear reaction are not affected by the changes in temperature, pressure, or the presence of catalysts. Also, nuclear reactions of a given radioisotope cannot be slowed down, speed up, or stopped. Another key. Three types of nuclear radiation are alpha, beta, and gamma radiation. What is radioactivity? Key terms. the process by which nuclei emit particles and rays. What is nuclear radiation? The penetrating rays and particles emitted by a radioactive source. Okay, radioisotope, an isotope that has an unstable nucleus and undergoes radioactive decay. Alpha particles, a positively charged particle emitted from certain radioactive nuclei. It consists of two protons and two neutrons and is identical to the nucleus of a helium atom. Beta particle, an electron resulting from the breaking apart of the neutrons in an atom. Gamma rays, a high energy photon emitted by the radioisotope. Okay. Electrons and the structure of atom. Unstable atomic nuclei decay by emitting alpha or beta particles. Often gamma rays are emitted too as well. Thank you so much, guys. We finished this lesson and